Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I'm your host, Dean Phillips, and I'm glad to be here. Today with me, of course, is Dewayne Lowe. He is from Transition Energy Group, where he is the president. Please welcome Dewayne. How are you, sir?
I'm good. Thank you, Dean. Thank you for that warm introduction.
It's great to have you here. Truth be told, we have known each other, I don't know, let's see, at least 15, 16 years since my first starting with Link Systems.
Yeah.
And that was back in your days at Whirlpool, and you were there, how, 26 years?
Yeah, just over 26 years.
That's great. You don't see a lot of that in business nowadays, but that gave you, I'm sure, a really good perspective.
Yeah, there was a lot of changes we witnessed over those 26 years. So, all good. It's all progress, right?
Mm-hmm.
So,
speaking of progress, tell us what your big takeaway is. What's the things you see coming down the pipeline here for us over the next 5 years?
Well, I guess one of the things, and this is kind of keeping in up with the current trends or what's happening in the world. Before, I guess, I looked at the U.S. manufacturing base as a very resilient, always, again, looking for ways to improve, cut costs, but to make a quality product. And, some of the strategies that the U.S. has had over the years has been a lot of outsourcing. And I think that right now, we have the supply chain disruptions as part of the pandemic. And those disruptions, especially, chip manufacturing has been a big one, but the supply chain disruptions and such, that I think caused people to take a look and say, okay, maybe this outsourcing strategy wasn't the best thing for us to do in retrospect. And I think there's going to end up being a resurgence of inshoring and even something called friendshoring, where you team up with some other small business to help that company to deliver a product for you to help you keep your production lines going. And I know that, my old company, Whirlpool, they've had a lot of disruptions from supply chain. I talked to a friend of mine just last night who was saying that, they're still having issues even today. And, we think that, hey, we are long past where we started at, and maybe we should have made improvements and evolved over that period of time, but it's still having an impact today. So I think that one of the things that I see changing in the next 5 years is a resurgence of small business. I think that during the pandemic, there was a lot of small businesses that went out of business. And I think that, you saw that decline in the number of small businesses out of there in the U.S. But I think there's going to be a resurgence in small business, but also a resurgence of bringing some of that production that was outsourced and offshored to places like China or wherever overseas where you had to have that shipping container to bring it in. I think that a lot of that, it was just like we're during the President's State of the Union address, we made a call out to Intel because they're going to be producing this mega chip factory in Ohio. So I think that there's going to be a big resurgence of bringing not necessarily everything, but at least not having all your eggs in one basket, right? So, basically all the chips for the U.S. were made, overseas, and so now there's going to be at least a portion of those are going to be made in the U.S., and it's probably going to be some sort of collaboration between maybe an overseas contractor that was making them for us, and maybe a U.S.-based entity that can make those, and again, kind of friendshoring instead of inshoring type stuff.
Yeah, I think it would be great to see, and I certainly hope you're right about that, because it would be really nice to try and have more of an attitude like, not to the degree like Japan is, which is it's always Japan first. Here in the
Right.
U.S., it's price first.
It has been for so long, and that's the thing is that it came back to bite us in the fact that the price has been such a major driver that we've been short-sighted in looking at what are the risks of that offshoring.
Right. Yeah. People that are waiting on cars or trucks or SUVs, I'm sure would have paid an extra $50 for a chip made here.
Yeah, it would have been a drop in the bucket, right?
That's right. It would have been nothing. They would have been more than happy to pay it.
Oh, for sure.
So tell us a little bit about your background. You mentioned, of course, that you worked at Whirlpool. Tell us a little bit about what got you into manufacturing and got you interested in that.
Well, actually, my introduction to manufacturing was with Maytag back then. I had worked for a couple of other companies prior to that, and I guess what I had done just prior to coming to work for Maytag was I was working in the predictive maintenance field and that industry, and I think that was actually one of the things that helped me get the job with Maytag at the time, because I came in as a maintenance engineer and supervisor, and the fact that I had a predictive maintenance background in the time when a lot of that was still pretty fledgling, there wasn't a whole lot of that going on in the world as a whole, and so I could bring that to the table. But that introduction to manufacturing really started from the maintenance side. So I came into Maytag back, in the day and worked as a maintenance engineer. And like we've talked before, there was so many opportunities for an improvement everywhere I looked. It was like, man, I can't believe they're doing this like this here. And my background was I'm a mechanical engineer, and so it was one of those things where I was like, man, this would be an easy fix. And luckily, when I first got there, some of the things, the policies and procedures that were in place, there wasn't a whole lot of structure around it. So when I first got there, there's like, if you see a problem that needs fixed, go ahead and fix it. And so I remember one of the first things I did, and this I had been there, a couple of weeks or whatever, and they're like, we're having this problem out in the oven cell. And, the equipment keeps shutting off. We don't have, we got an air pressure problem. And I went out there and I looked and I'm thinking, man, this is not an air pressure problem. You have an air volume problem. You don't have enough volume. And I said, we had a morning meeting every morning, and I went to that meeting. I said, I can fix that problem in just over the weekend. They're like, do it. I said, okay. So I made a few phone calls, got a 1,000-gallon SCME tank, lined up a contractor, and over the weekend we installed an air receiver tank out there, and we fixed a problem that they'd been struggling with for, 5 years. And it's like, man, I can't believe that we were able to do that quick. Well, it's not the same today because there's a lot more, things that you have to go through today than I had to go through back then to be able to get improvements made. But that's really my introduction to manufacturing, was from the maintenance side back when I first started with Maytag.
Yeah, and I think that people underestimate how important those small changes can make in everything, because people limp along with what they do today without embracing technology. Somebody can sit in their garage and use a hammer all day long to make parts, and that's fine. You're in your garage, but all of a sudden you move that from there over to a hydraulic or a pneumatic press that can do that in half the time with half the energy. Yep. And it's amazing. But when you try and work on the efficiency of doing a bad process, and if you're sitting there with a hammer all day long, you probably need to look at and explore the new technologies. And do you think that that's one of the areas that people can gain some traction in now?
I think it is. When you talk about that, a set of fresh irons, for example, the person is using that hammer day after day, and they kind of get tunnel vision. They're just doing what they've got to do, and they really don't even think about, hey, there's a better way of doing this. But in everything, there's a quote I love in it, from Thomas Edison, is there's always a way to do it better. Find it. Mm-hmm. And that is so true. And it doesn't matter. For example, we had a gold lead facility, but there were ways to improve the energy efficiency or the sustainability of the operation that we had. I know that Volkswagen down the road is a platinum lead certified facility. I guarantee you there's ways to improve what they're doing inside. So a lot of times it just takes a set of fresh eyes. We used to have these things occasionally where, we would have people from maybe a different, one of our sister companies would come in and we would review something, and just that set of fresh eyes, and they may ask something and say, look, I don't necessarily understand your process, but I'm going to ask this question. And then ask a question, and it may trigger something in your mind going, I don't know why we didn't ever change from, hitting this thing with a hammer every day to making something that was automated, Right. And so just that set of fresh eyes can bring a lot of change and improvements to something that, really somebody else may think, oh, that's a common sense type thing that you should do. Yeah. But to you, it's kind of get caught up in the repetitiveness of it.
Right. I use the comparison all the time of, somebody, you go into a place and there's a leak in the roof. Well, mm-hmm. A new person, they go and they say, hey, there's a leak in the roof. But everybody else just walks around it. They just walk around it, walk around it, walk around it, because they know that it hasn't been fixed, and that is how they deal with it. Or somebody will put a bucket there, and everybody just walks around the bucket, but they don't address the problem. And it's what they call in psychology, they call it a scotoma, where you can't see it. It's if you've ever seen, there's a video out there that talks about kind of this same topic, is when, as you mentioned, being so myopic, there's a video where you're supposed to count the number of passes, and you can find it on YouTube, and they're passing, you got to count the number of times that somebody in a white shirt passes the ball. And there's people in white shirts and black shirts, but you don't even notice, because you're so focused on the white shirts, that a gorilla walks into the scene and through it, because and it's very difficult, and most people don't pick up on the fact that a gorilla has just walked into there, and not just subtly, it has walked right through the middle of the scene, and you don't even see it because you're so focused on the people in the white shirt, and that you overlook the problem that you're not seeing. And it brings up a lot of the situations that people have, even with energy, talking about where we could take technology to reduce our energy usage. Things like IoT, measuring motor usage, measuring bearing failures. No longer is it acceptable to wait till the bearing fails, because you've been wasting energy for a long time when a bearing is failing.
Oh, yeah. Well, one of the things, too, and again, my background prior to coming to Whirlpool, I worked in predictive maintenance, and you're talking about measuring that bearing or that motor. One of the things that I did prior to coming to Maytag was I did training on machine alignment, so shaft alignment. And one of the things that you could measure, for example, is if there was a misalignment in a shaft between a motor and, let's say, a fan or a pump. Due to that misalignment, that motor would have to have more power to operate it. It'd heat up. So you had all these additional weights that ended up, ultimately being extra energy to be able to drive that motor, because of that inefficiency due to the shaft misalignment. So, if you can measure those things. Now, I doubt that there's very many people out there that are measuring it down to that point that, hey, I've got device that's on this motor and on this bearing that I'm taking back and I'm relating it to energy consumption, they're typically looking at, for example, if you're looking at predictive maintenance, they're typically looking at those inputs to determine when a machine is going to fail and trying to take care of the machinery and the process so that you don't have a disruption, and you, again, predict when the equipment will fail so that you take some action before it fails to keep the process running, right? So if you have to replace the motor, you replace the motor instead of maybe going in to correct the misalignment problem that really is the root cause of the thing. Maybe then your motor will last 2 or 3 times as long, and your energy reduction, may be 10, 20% less than it was with the misalignment. But I there's not a lot of folks that I'm aware of, at least at this point, that are taking that data from a maintenance standpoint and relating it back to energy.
Well, it's interesting you say that, because one of the challenges that I've always found is that getting information is not the hard part. It's understanding it, interpreting it, and acting upon it.
It is.
There's a lot of times, for instance, in the stamping press world, as you talked about of energy usage, there's a counterbalance. The counterbalance that's on machines is there to counterbalance the weight of the machine. Well, consequently, what typically happens is people turn it all the way up. They're like, well, if 40 PSI is good, 60 PSI is probably better. But now it acts as a brake the entire way down. So it's wasting energy that whole cycle. And if people just put an amp meter on in the downstroke and the upstroke, it should be the same. That means you're properly counterbalanced, because
so you don't even realize the weight of the die is there, right? Mm-hmm. That's what it's supposed to be.
That's right.
Exactly.
And it's so true, though, that people, if they could see that, they also need to have the understanding of what that means. Another part of that problem is things like turning up your clutch pressure. So if you have too much clutch pressure, then the brake has to work harder to work against that, because it stays on longer. The clutch stays engaged longer. It's being hit with more pressure than it should. Its travel is greater now, because as the clutch wears, people often don't understand that if the clutch is worn, you're going to wear your brake, because it has to work harder. And
it's like you said, it's a balancing act, so that, and typically, again, people are not measuring the energy that it takes, or the energy that is lost through that inefficient operation of that equipment. And not only, so it goes farther than that, right? So it's, again, going back to my background prior to that, is in maintenance, is not only are you wasting energy, but you're adding unnecessary maintenance on the equipment that, again, it may last twice as long. Those brake pads and that assembly may last twice as long as if you were to have it, properly balanced.
Right. You're shortening the lifespan.
Shorten the life, and when you think about the counterbalance, right? So now I'm also putting undue wear on those bearings, right? So all the bearing surfaces in there. So not only am I acting like a brake, but those bearings are trying to work against that. It's additional friction in the whole system. So any friction, again, is going to go back to wasted energy through heat, and you're wasting energy. So
right, it's. How do you see some of the changes coming from energy? How can we better utilize it? What are some recommendations you have?
With regard to the operation as a whole, or just the way? So, some of the stuff that is happening in the world of energy, we'll say, is obviously there's a lot of innovation, a lot of research and development that's going on towards renewable energy and, reducing our carbon footprint. And I think that what I see, at least in the future, is that, we're going to be having more options for how we get our energy right now. And this has been the way that, let's say for the last 20 years or maybe further than that, you hook up to the, local utility company and they provide the energy you need. And really you don't pay much attention to it other than that. Mm. But now, if you look at your energy footprint, let's say, for example, in your operation, and what does my demand curve look like, and how am I being billed based off that demand curve? Because obviously there's, and maybe I say obviously, there are a lot of different pricing structures that are out there depending on how a company utilizes energy. Mm-hmm. And if you are a high demand plant, you're going to pay more in demand charges. If you can get that peak kind of shaved off and you're kind of level loaded, you'll pay less in demand charges and more in energy charges. But really, when you look at your bill, you've got an energy portion of that and you've got a demand portion of that, as well as other stuff. Now, with the introduction of renewable energies and stuff like wind energy or solar PV cells, those don't necessarily operate all the time. So the capacity that they bring to the grid is not necessarily stable. Mm-hmm. So if you're just saying, okay, we're going to bring in solar, for example. Well, it's great when the sun's shining, but when the cloud comes over, you have a storm, there's a lot of volatility in the capacity that product is actually delivering to the grid or delivering to your plant. So one of the things I see too happening especially in this area, their pricing structures are being put in place because of the use of things like solar and wind, because it really puts a lot of volatility back on the TVAs and the Duke Energies and these places like that are producing and trying to keep places from going into a brownout situation. Mm-hmm. But they're trying to produce and they're trying to match that production curve to the demand curve out on the grid. And if, like I said, is that maybe you've got a 50 megawatt solar farm that is producing, and all of a sudden a storm comes over and that 50 megawatts goes down, and now you're only producing, 15 megawatts. That sudden drop off, they've got to make it up some other way to try to balance the system. We were talking about, balancing and counterbalance there. So mm-hmm. You got to have that balance of demand to supply on the electrical grid as well. And I think that the renewables are great, but you really have to bring in a component of storage. Mm-hmm. And, the storage is one of the things that maybe is there's a lot of R&D going on in storage right now. There's, encouraging the fact that there are, but really today, still the biggest storage systems we have is pump storage, right? Mm-hmm. So have you ever seen the Raccoon Mountain facility TBA's got? Mm-hmm. It's awesome. I've been through tour on that. This was all prior to, 9/11, but I've been through a few times on a tour through that facility. It is awesome what that is doing, but basically that is kind of like a battery in effect, and the fact that it stores energy and it releases that energy when you need it. And that's what we're going to have in some form of capacity out there for operations that are choosing to put in solar so that, it makes sense, right? So that they produce the energy, store it, and use it when they need it, instead of trying to go from solar panel to the grid is not necessarily a very smooth transition there.
Right. It's interesting you say that, because I've been lucky enough to go through the UT Space Institute a few years back, And when I went through there, one of their things that they were working on is these frictionless or zero friction bearings to try and get unity transfer for their energy. What they wanted to do is that, as you mentioned, batteries are not the best long-term stable storage solution. So they were using flywheels, so the energy would go into this flywheel, and then they could control a lot there. And as long as the bearings weren't absorbing too much of the energy through friction, they were able to maintain the batteries longer. They were able to kind of keep that recharging going, because now they were able to recharge through this through the flywheel system, and it looked very promising. But again, that's another one of those things that, does it work on a business scale? Probably not right now, but this was working with NASA too. That how do we go about making this also a private sector thing? It's not. Most of the government agencies now have to make things viable. You can't just keep getting government money. You have to have some private entities involved.
Yeah, you can't just always do research and development. It actually has to produce something eventually.
That's right. There has to be an end goal here where it's going to make back this money. So
it is. And to that point, again, it's kind of one of those things when you look at the commercial viability of some of the research being done out there. It's like, it's a good idea. I like that fact that they're thinking, outside the box and trying to create. And so when talking about that, all the activity that's going on in developing and really thinking outside the box for coming up with creative ways to solve problems, that is encouraging. And I think that it will eventually lead to some gains where, one of the things, for example, there's been a lot of direction towards lithium-ion batteries for electric vehicles or for other storage applications, let's say for solar systems.
Mm-hmm.
Well, those are good for portable applications, and I won't say that they're not good for stationary applications, but there are better alternatives for stationary applications for storage of energy than maybe a lithium-ion battery, and the materials for a lithium-ion battery are expensive to get to mine. And then also, how do the recovery and the sustainability of that whole lithium product comes into question. So there are now, since phosphate batteries, which has got a lot of the same inherent properties as far as what it will produce and how it will work that the lithium-ion does. A lot of the same type of discharge curves and such, and recharge capabilities, that they're less expensive. But then even at that, flow batteries and other storage, like you're saying, the flywheels, and I've seen other ones where they're doing energy storage where they're lifting these concrete blocks up with these big cranes, and all that looks great. But I'm thinking to myself, okay, there's this big crane out there with these big 30-ton blocks lifted up 300 feet in the air. What happens if there's a tornado, or what happens if this happens? What happens to that? And so when you look at the risk of those things, here's another thing too, and this is something that probably a lot of people don't know. I know I had a friend of mine that I used to work with, that he had put in solar panels at his home, thinking that he was going to be able to, he was going to put it back on the grid, sell it to TVA, and it was going to offset the cost of the power that he was getting to his home. And he was sorely mistaken when he found out that what they were actually paying for the energy he was putting back on the grid was very minute compared to what they were charging him for the energy.
Right.
And but then again, if you're putting in, I'll tell this for everybody, if you're putting in a solar system today, you need to be looking at some sort of a storage option so that you can put it on your side of the meter, and you can use your operation. And then I won't say that it's still a good payback, but a whole lot better of a payback if you've got storage capability of putting it on your side of the meter than it is if you put it on the grid side and you're going to supply it to them and then get some sort of credit. That really doesn't work because what's happened is, the energy producers have gotten wise of this, and they were, I guess, in the very beginning giving a lot of incentives out for this, but now they're not incentivized for
Nope.
that. It's actually almost the opposite.
Right. Yeah. And I've told people that the other day. I was talking to somebody who was talking about putting the roof panels on their house, and I said, well, before they were giving out grants and things, they were helping to compensate you for that, the install and everything. Then that went away. Then there was also, they were buying the energy back at market price. Well, some of them aren't even buying it back, only to your usage level. So you can only recoup to a net zero. You can't sell it because people were, some of these big companies were starting to build these solar farms, and then they were wanting to basically make a profit off of it. And the electric companies, oh, no, you're not.
yeah, that's right. One of the things, and I watched the video, and it was a podcast video that I saw several months ago, and it was where in California that they were using residential battery storage. For example, if I was a homeowner in California and I'd maybe put in a Tesla wall system, let's say, for example, and I had, a certain amount of capacity based off I had solar panels on my home and I was bringing that in, but then I had extra, capacity so that if there was some sort of outage event, I could last maybe a week, let's say, for example. They actually are buying that energy back to help with keeping the grid stable in California. They're buying it back from actually residential users, which is, I think, pretty novel idea. We're not doing anything like that here in this side of the U.S., but at least, that's encouraging. I think maybe the other folks will look at that and maybe do something similar down the road. But I know that at least one of the local power companies in this area, I had talked to one of the VPs a few months ago about solar systems and such and battery storage, and they have themselves put in battery storage for their system to help. Again, it's kind of one of those things to help peak shaving because, so companies typically get penalized if, I won't say penalized, there's a component where you pay for demand and you pay for energy, right? But if you have something, let's say that you start up a process and you have a peak demand that goes up maybe 3 times of what your normal operating demand is, guess what? You're going to pay for that peak demand, not what your operating demand is. They don't average it out. Well, you averaged it over, because the reason is that producer has to have that capacity available, so they're going to charge you for that capacity they have available.
That's right.
So if and the local power companies, they get hit with the same type of thing. So if maybe you're a company and you're produced or your demand is served by a certain LPC, and then they're served by this other entity, it's a trickle down effect, and everybody gets hit with whatever it is that the end user is causing. So there's LPCs out there that are actually now putting on some battery storage themselves for helping do some peak shaving. Yeah, so I think it's pretty good, novel idea, way to do that, combat it.
Right. So we're just about out of time here, Dewayne. Tell everybody how they can get in touch with you.
Well, so you can go to my website. Again, it's fairly simple, transitionenergygroup.com. So it's all one word. There's information on the website on how to get in touch with them, my phone number, email address, as well as information about the services and stuff that we provide. The thing is, like I mentioned in the beginning, there's not every company is the same, right? So when you go in and you look at an operation, you talk to someone on the phone, what is it you produce? How do you operate? What times of day? it gets into almost everybody is different in the fact that there's not a cookie cutter solution for everybody. It says, okay, if you do this, everything will be great. No, you really have to talk to the folks and develop some sort of customized solution that works for them, because the other thing is not everybody has the same risk tolerance, right? Mm-hmm. So if a company, is very risk averse, maybe they I don't want to go down that path. For example, demand response is something that we've done at my former company. The whole time that I was there, we were on the IP5 program where we had to shed our load within 5 minutes. If TVA called and said they needed our power, we had to shed our load within 5 minutes to give that back to them, and again, to keep the grid stable. But, that doesn't happen all the time where they call for that, but you have to have a tolerance for that risk. There's reward for that risk, but you have to be tolerant for it. So if you're not tolerant for that, that's fine. There are still improvements that could be made to your operations, and what we can help you with is do some auditing of what you do and how you do it, and try to come up with a plan that works best for you, customized.
Great. Well, I appreciate you being here today. It's great catching up with you. Thank you for your insight, and you go have a great day.
Thank you, Dean, and you have a great day too. I appreciate the offer to be on the show.
Thank you.